All right, let's do some problems. The ball is projected horizontally at a velocity of 10 meters per second from the top of a 50-meter high cliff. Draw your trajectory. They're asking you to find the time in the air, so t hang, and we want to know range. So those are the two things we're trying to find. I'm going to make my chart. So we've got the x component, the y component, v initial, v final, a, b, t. Initial velocity on the x is 10 meters per second. There is no y component. It's not moving up and down at all. This is constant speed, so that's 10. This is 0. The range is what we're trying to find. The time we don't know. We want to find that also. We just know that it's equal on both sides of this divider line. This is negative 50 because it's falling 50 meters. This is negative 9.8 because it's always negative 9.8. We don't know the final velocity, but we're not being asked to find it. So I'm going to find the hang time. So to find the hang time, we're going to do delta dy equals v initial y plus 1/2 at squared. All of these vectors are y components. I often don't write it, it's easy, but this should, now all you got to do is plug in the numbers you have. This is 0, this is negative 9.8, and now you're just doing your typical kinematics problem. So you've got negative 50 equals negative 4.9 t squared, right? The term drops. So 50 divided by 4.9, and take the square root of that, and you get 3.2 seconds. Then, to find the range, or the dx, it's v initial x times t plus 1/2 at squared. Since acceleration is 0 here, that goes away, and you can just plug in 10 times the time that you just got, and you'll get 31.9 meters. Or 32. You can put 32.0, that's fine as well. All right, so number 2, a ball is projected horizontally with an initial speed of 8 meters per second, and they tell you that the time is 0.8 seconds. And you're asked to find the initial height and the range. So again, I'm going to make my chart. This is 8 meters per second. This is 0. 8 meters per second. 0, negative 9.8. Those are given, so those go in right away. We don't know this or this, but we do know that this is 0.8 seconds. So this then becomes a pretty simple problem. You'll notice we're going to use the exact same equations as we did last time, but the given and unknown are different. So we're looking for dx. This is 0 times 0.8 plus 1/2 times negative 9.8 times 0.8 squared. 0.5 times negative 9.8 times 0.8 squared gives you negative 3.14 meters is your delta dy. This goes to 0. And then for the other one, it's delta dx equals v initial x t plus 1/2 at squared. This again goes to 0. So this is 8 times 0.8, which is 6.4 meters. So that's how you solve the